This is kind of a sad one, I know. And I put this at the bottom 50% end in divorce because, I mean, how could I not do that joke, honestly? Angle relationships. Well, I mean, he's a complimentary and I'm supplementary. We just couldn't get along. Well, A type personality, B type personality. It's, birds of a feather flock together. Okay. So the thing that we talked about the most, and the thing that was the most important, because you already know what a right angle is. You already know how many degrees are in a triangle. You already know how many degrees are in a quadrilateral. You know how many degrees are in a full transversal. You know how many degrees are in a straight line. You know what an acute angle is. You know what a obtuse angle is. So the thing that we really have to differentiate between is how are we going to do our math, and that's based on these two words. Complementary, which was the shortcut, you can just turn it into 90 by putting a line on the C. 90. If you know that that one's 90, then you know that the other one is 180. And if you wanted to get real creative, here is the real creative way to make that 180. It's almost like I completely changed it, but I mean, if you have to, that's how I go about doing it. So a complementary is anytime you add two angles together and it equals 90. So 45 and 45. Make one right angle, which would also be complementary angles. They complement each other. Hey, 45, how are you doing? I'm doing great, 45. How are you? I liked what you did with your hair. Hey, let's make 90 degrees. Then supplementary would be like, hey, 90, come meet with me. I'm 90. And be like, well, thank you for supplementing my angle. All right, so the thing that is going to start getting mixed in, just like when we started throwing like the dot in or parentheses to show multiplication, is there's going to be a thing that looks like a less than symbol that's going to mean angles. Here is less than, here is angle, if I wasn't shaking from too much coffee. So this we already talked about was whenever you go and you make half of a circle, all right? If we made a whole circle, you told me 360 degrees. Okay, you spin around in a full circle, you're, 360 degrees. Xbox 360, right? It's got a circle, box, all quadrilaterals, box, 360, 360 degrees, four right angles, 90, 90, 90, 90, makes 360. So if we know that from one side of this line to the other side going around it, we know that that's going to equal 180 degrees. So let's go ahead and label what we know. We know that this bad boy right here is 57. So there are two ways. One of which is algebraic, and that's probably a way that you're going to be asked to find the answer. So like you don't have to solve the problem necessarily, but which problem is set up, A, B, C, or D, that would help you find the missing angle. There's ways to go about that as well. So here's the first way. All right, we don't know what angle 1 is, so that's x. You already said that you know this equals 180 from one side to the other. Okay, so angle 1 plus angle 2 should equal 180. And ultimately what's going to happen every single time is you're going to end up balancing this equation, and I'm going to show you the part where it just works out to be common sense math. Is if you're adding 57, you subtract it, it'll work backwards because you're finding out what's left. And whenever I use the phrase what's left, you immediately said, oh, okay, so I just subtract. And look at this. What's happening right there? Subtracting. Okay, so algebraically, that's why algebra is logic. Like you're going through and you're rewriting something so you can mathematically solve it, but ultimately it ends up being the thing that you're going to figure out anyway. So 180 minus 57, I'm not even going to risk it. I'm using a calculator. 123. Now, there's another way that you can go about checking this answer, 123. I'm going to go ahead and write it in here. X is 123. All right, so when you're looking at angle 1, you can go like, that looks larger than 90 degrees. It says it's larger than 90 degrees. So it must be obtuse. Angle 1 is obtuse. 123 degrees is obtuse. That's a really good way just to do like a surface level check. And then also you're looking at angle 2 is 57. If it's going to be a supplementary angle, then it's going to be 123 plus 57 equals 180. So that means if you have one obtuse, you have to have one acute. So 57, it looks like it's acute, and it actually measures acute, and I can double check it by adding 123 and 57. It should equal 180. Check, 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 check. All right, now for the logic version of I have 57. I know it's supposed to be 180. What could I do? That's the easier way. Now, if you feel like solving it algebraically because that's what makes more sense, do it. All right, weird little thing that's not the less than sign, but looks almost exactly like it. Thank you, mathematicians, and your Nobel Prizes. All right, so angle 5. Angle 5 is 22 degrees. So this is somewhat deceiving, all right? So it looks like we're going to try and find something out of 180 degrees, but there's also a symbol that tells us more information. So we were only given one thing, 22, but then there's a symbol that gives us something else. This is 90. Couple things we already know. Here to here is 180. And we know that if we have 90 degrees right here, that 5 plus 6 should equal 90. Angles 5 plus angle 6 should equal 90. So there's two ways we can go about doing this. We could do it algebraically. We don't know what angle 6 is. X plus 22. We know it's supposed to equal a right angle because 90 plus 90s are supplementary. So right now we're looking for complementary. Equals 90. Okay? Minus 22, minus 22. Just like fraction. What you do to one side, you got to do to the other. What you do to the bottom, do to the top. X equals 90 minus 22. You know what? I'm not even going to risk making a mistake. I'm not even going to risk it. 68. So 68 degrees. So we know that anytime we're finding complementary angles, that we know that both of them are going to have to be acute. Because if any of them were larger than 90, then we'd be finding an obtuse angle, and that wouldn't ever be able to equal 90 for a complementary angle. So far, 5 and 6 look like they're right. If you added 22, 68, and 90, you would get 180. The logical way or the quicker way to go about doing this is, all right, well, I know that it's going to equal 90, and I have 22. What's left? So whenever you're talking about your theorems, try and eliminate stuff. All right. So whenever we have, this is two right angles next to each other. If you add 5 and 6 together, that's a right angle. And you could go ahead and do this. And it's true. And you knew that before you even found 68. So when you're looking at your theorems, the best way to approach it is, what is it not? And then start crossing those out and going, it's not this one, it's not this one, it's not this one. Because if you can sit there and find at least one or two where you can sit there going like, it has this, it has this, and it has this, and it has this, at least you can debate whenever you're in a tough spot of going, I've narrowed it down to these. This is the one I feel fits the best. We're not geometry professors. That's how we got to do stuff. All right, so angle 1, not a less than sign. I know. It take getting used to. 38 degrees. So angle 1 is 38 degrees. This is where the theorem that is incredibly awesome because of geometry rules, you said vertical angles. Vertical angles are always equal. So we know that a vertical angle 1 to 2, that's going to be 38. A thing that I told you to be more thorough is if you know from this arrow to this arrow is 180, then you know you have that to figure out. It's always best to just make sure all the pieces fit. You don't even have to figure out what X is. I just like to go ahead and be as thorough as possible, fill out what every angle could possibly be, and if something looks like it's off, because we know that X should also be right here because they're vertical angles. So once we do 38 and take it away from 180, I'm not even going to risk it. Obviously, I'm not risky today. 142. Okay, it makes sense. It looks extremely obtuse. It's very obtuse. If you added up all four of these numbers, you should get 360. And you can see here that the rule of vertical angles holds true because we have 38 and 142 over here as well. That's why vertical angles are always equal. All right, so I'm just gonna stop commenting on this because I feel like it's lost its oomph. I'm gonna go ahead and write what angle 13 is. So whenever we talked this one out, you didn't have any problem saying like, all right, well, angle 13 plus angle 14 should equal 180 degrees. And I was like, score. And then I was like, okay, so you said 13 plus 14 equals 180. You know, yeah. I'm like, okay, well, how could you add these two things together? And you're like, I don't know. I said, this is where your like terms comes in, bruh. And you're like, I remember that word or words, but I don't remember what it means. I'm going to show you again. So look, I'm adding them just like you said to do. There's the first part. There's the second part. I'm adding them up. So obviously I can't put 4x's with 11, right? So I mean, those are unlike terms. Those terms are not like. So I'm going to do them highlight the stuff that's the same. I can put 4x's with 3x's, and I'll just have more x's. They all live in Texas. Is that the second breakup joke in this video? It is. 4x's plus 3x's is 7x's. And then I can, just mark these out. Check, check. Got those done. All right. And then I can do 11 plus 1. Absolutely. I know what that is. It's 12. And then I rewrite it. Now we have a two-step equation. We got to get x all by itself. So that means we get rid of the 12. See you, 12. Oh, no. And then 7x equals, again, not feeling confident, 180 minus 12, 168. Why not? I don't even know why you wouldn't use the calculator. Save your brain for something else. Now we're down to a one-step equation. Thank goodness. So we're multiplying by 7, so divide by 7. X equals, all right, 168 divided by 7 is 24. And you're sitting there going like, heck yeah, I already had that like way before you got to it. That's the answer. Yeah, x is 24. No, x is 24. Don't get me wrong. Yes, it's true. But we're not done. So, all right, cool. All right, you're like 13, 14. I found x. Yay. What the heck is that for? Oh, I can put 24 in for x. That'll tell me how many degrees each angle is. So I know that this one should be larger than 90, and I know this one should be less than 90. I know that them combined should be 180. This is where the magic happens, folks. This is why we pay teachers millions of dollars. 4 times 24. I'm substituting it in because it said 4 times x plus 11. And you're like, what do I do first? Come on, man. Order of operations. Every time you're doing math, order of operations never going away. 4 times 24 should be 96. Should be. I'm just going to check. 4 times 24 is 96. Genius. Plus 11. 96 plus 11. Not even going to risk it. 107. We said that was supposed to be obtuse. Skiggity, skiggity score. That's obtuse right there. That's larger than 90 degrees. All right, so checked out so far. Next problem. 3 times 24 plus 1. 3 times 24, 72, I guess. 3 times 24. Dang, all right. Maybe I should trust myself more. Plus 1, 73. All right, you said the other one should be acute, and look at that. Less than 90, acute. And then we said when we add 13 and 14 at the very beginning of the problem before we wrote any of this stuff down, it should equal 180 degrees because we're going from one side of a straight line to the other, half of a circle. So when you add 107 plus 73, you get 180. Check, 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 check. I don't even know what to put there. So all of these things we just did were all methods of checking. Now, whenever you come to stuff like this, just make sure you're finishing the problem. Once you find what x is, substitute it back into things that don't make sense. 13 is actually 107 degrees. All right, there's boxes. There's a thing that looks like a person's head here. You know, it's like, I don't even, weird hair. All right, so weird things that are angle symbols. Okay, wow, that last one's not good. All right, so here's what we know. When we add angle 9 and angle 10 together, they're going to equal 90 degrees. Okay, so 9 and 10, what we can do is let's go ahead and make that be 90. I'm going to go ahead and just label this as these two together should equal 90. So since we have it on a straight line, we know that 7 and 8 should be the exact same thing. Oh, we know that angle 7 is equal to angle 9. So whatever angle 7 is, it's going to be the same thing for 9. That's convenient. So it says 8 is 41. Okay. So you're sitting there going, how the heck am I supposed to figure out what 7 is? Well, if we know that this whole thing here to here is 180, and we know that these two are 90, that means these two are 90. So we can go algebraic on it, x, or the letter of your choice. I prefer to use, I almost did a third breakup joke. I'm not going to. You know what? I'm just going to do the problem. X plus 41 equals 180. One-step equation, minus 41, minus 41. X is equal to 139. I feel comfortable with that one. Oh my gosh, that was an easy part. Wait, what in the heck? 139 degrees? Does that look like a 139 degree angle? No, it doesn't. It looks extremely acute. Oh, I used 180. That's why we do this stuff. That's why we look at it over and over and over. That's why we go through some self-talk before we approach the problem. That's why we look at it and go, you know what? This should be acute. Should be 90. That's what we put this whole symbol here for. Let's go put it over here. You know, make notes for yourself. So x plus 41 equals 90. This will help. This will be way better. Minus 41, minus 41. That goes away. X equals 90 minus 41. Who knows? Like you could guess it. 49 degrees. That's acute. That makes sense. 49 degrees. Okay. So if we know that 7, see look, 7 and 9 are equal. They're the same thing. So 49. And we already know what the other half of a 90-degree angle is if, well, it's not actually half. We know what the other angle is out of 90 degrees if one of them's 49. You just did that. 49, the other one's 41. If this one's 49, that means this one's 41. When you add them all up, you should get 180. Guess what? You do. So I know that there's a lot of talking going on, but that's the kind of stuff that's going on in my head with the stuff that I know. I'm like, okay, that's 90, that's 90. I know I've given this one. It says that this is equal to that. One piece at a time. Oh my gosh. All right, so this is where you're like, vertical angles, bro. And I'm like, for real? All right, and then 3x plus 4. All right, so the thing with vertical angles is you said, hey, Mr. Foz, those are equal. I'm going to go, yep. So you'd use the theorem of vertical angles if you needed to come up with a theorem for this one, because it's the only one that mentions vertical angles, and this is the only thing that's in this. So you said they're equal. This is a multi-step equation. Okay? Just like you said, angle 2 is equal to angle 3. All right? So my advice when solving multi-step equations is start getting rid of the thing that is less x. You're like, what? All right, so whenever you're looking at 4x and 3x, which is less? 3 is. Hey, good answer. So I'm going to get rid of that. It's a positive 3x, so I'm going to subtract 3x. This is math with like terms. Notice I did not put it underneath the 26. It doesn't have an x next to it. I can't take x's away from a number. I have to take them away from other x's. That'll leave you with 4 over here. minus 26. 4x minus 3x equals x minus 26. Okay. Oh, dang, we're just down to a one-step equation. That was easy. So now it's minus 26, so let's do plus 26. X will equal 4 plus 26 is 30. I'm done. And you're like, nah, because I remember that last problem we did with this stuff. Exactly. We know what X is now. So now we have to solve these two problems using the answer we found for X. And let's not pretend like you didn't know that, all right? We both know that you knew that, and you were calling it from the very beginning. 4 times 30 minus 26. So that's 120 minus 26 should be 94. 3 times 30 plus 4 is 90 plus 4. That's 94. Wait. Why are they the same? Oh, yeah, because they are vertical angles. That's how you know. You're like, okay, if these are vertical angles, the answer should be the same. Now, technically, what you could have done is if you solved this one over here, you could have gone, well, I already know the other one's going to be 94. But just to make sure and be thorough, we went ahead and solved the other one, and we proved it. 94, 94, yeah, smack dab. Diggity dog, those are vertical angles. So the more practice you do with this, the more times that you're looking at just random intersecting lines and you're just solving. You did this a ton in 8th grade, so just keep on looking through the vocabulary. Vertical angles, supplementary angles, complementary angles, adjacent angles, anything you can possibly, alternate exterior, alternate interior, all of those. Take a look.